Looking at the past year, we made significant strides in provisioning Southern Polytechnic State University with contemporary and best-of-breed information technology resources, positioning the university for innovation and collaboration, improving the level and quality of IT services to the university community, and building an instructional foundation for making data-driven decisions. In addition, we established exceptional support for new modes of teaching and learning. While lowering the total cost of ownership, we supplied cost-effective services to inform and enable faculty, staff, and student success.
The need to interact and compete globally has now reached higher education. Extending the reach of our institution to create new opportunities for access to education, accomplish state and national goals for college completion rates, and build on the exceptional reputation and brand of our university as a technology leader requires a robust institutional technology program and environment. This year, University Information Technology Services, now known as UITS, accommodated such requirements through closer collaboration and interactions with the university community, build-up of technology infrastructure to support new, more current models of computing, advancement of data environments and capabilities, and new and expanded managed services in support of academic and administrative technology stakeholder needs.
The focus for this year involved restructuring. Restructuring included how the University Information Technology Division was staffed, how it supported infrastructure, applications, and services, and how administrative and academic stakeholders achieved value, efficiency, and mobility in their computing experiences. Moreover, restructuring included a cultural change in how the university technology community works together to achieve the university mission and vision. New operating principles and values guided a rebranded information technology organization to achieve new levels of technology innovation, socio-technical value, and service. Creation of a new service catalog to define and set expectations for service levels, along with the help desk as a single point of contact for information technology services, represent ethical elements of this year's restructuring efforts. The newly named and rebranded division, UITS, communicates its message via its website at www.spsu.edu/UITS.
Southern Polytechnic State University stakeholders play a major role in the design, development, and delivery of IT services. As such, stakeholder involvement in establishing priorities, technology planning, risk, policy and best practices, and decision-making with respect to the use of academic and administrative technologies are all important. Shared governance involves stakeholder input in two primary university areas: academic computing and administrative computing. The first committee, Information Technology Advisory Committee, or ITAC, represents faculty interest in the area of academic computing. The second committee, Administrative Information Technology Advisory Committee, or AITAC, is currently in formation and is intended to represent staff interest in administrative computing.
The faculty ITAC represents university faculty interests and needs in the area of academic computing. Specifically, this committee works to achieve strategies and designs that incorporate pedagogy and technology. Moreover, the committee provides direct input and feedback to the Chief Information Officer through regular formal committee meetings, and in return receives direct briefings from the Chief Information Officer regarding University Information Technology Services progress towards its 3-year master plan.
In keeping with the requirement for secure and available IP traffic flows in and out of the university, 3 core network firewalls were replaced with one next-generation firewall. The term next-generation firewall refers to devices that go beyond the traditional firewall functions by adding security capabilities such as intrusion prevention. This year, the university completed the migration to a Palo Alto device, a next-generation firewall.
Palo Alto Network's next-generation firewall allows Southern Polytechnic State University to safely enable applications and strengthen its security posture across the entire institution with firewall policies that use business-relevant elements such as application, identity, who is using the application, and the type of content or threat as network access decision criteria. The university's new Palo Alto firewall serves to support parallel packet filtering, data filtering, IPS, IPv6, URL filtering, virtual systems, VPN, device management, and modern malware protection.
Campus networks are only as secure and available as their weakest links. Inferior wiring and networking infrastructure serves to radically degrade network performance, availability, and reliability. In many cases, university network infrastructure is dependent on joint space use with facilities management, campus services, or other space-available locations. As a result, expensive and critical university network components are subject to unauthorized access, extreme climate conditions, unregulated environments, and less than pristine conditions that adversely affect the operation and performance of network components. This initiative will work to improve critical campus infrastructures and junctures through physical upgrades, relocations, consolidations, and construct new facilities known individually as a node nexus to support improved network security, availability, reliability, scalability, and performance.
As part of this year's IT Infrastructure Buildup Initiative, 3 old and poorly conditioned wiring closets have been replaced with new node nexuses. A node nexus represents a 21st century concept to network design in the construction of a secure, available, and environmentally controlled destination for all data, voice, and video traffic within a building. The first node nexus to be completed involved Building H on the 2nd floor, followed by Building R, Norton Hall, on the 3rd floor. A third node nexus is scheduled for completion in Building I, Architecture Design, to provide connectivity to the building wireless and wireline infrastructure.
Cloud computing infrastructure conventionally relies on hardware servers that are clustered together in a grid configuration and then virtualized to provide virtual machines that can host applications. This year, UITS installed and configured 5 new server clusters to support the university's move to a business intelligence platform, administrative and library virtual desktop infrastructure, and university-managed hosting. This essential buildup of server cluster infrastructure adequately prepares the university to support cloud computing services such as infrastructure as a service and software as a service. Managed hosting is now successfully used by campus services and other university stakeholders.
As part of the 3-year IT Master Plan, a buildup of data center resources in support of cloud computing launched this year. The data center was upgraded with 5 new server clusters to support virtual machines, virtual desktops, business intelligence, and managed hosting. Moreover, the upgrade moved the university significantly closer to operating with a private cloud model. Cloud computing represents an architecture and model of computing designed to deliver infrastructure, platforms, and software as constructible computing resources on demand to networked users. As SPSU is challenged to better accommodate academic needs for applications in computing environments, private cloud computing will provide an accommodating solution for mobile, campus laboratory, and anytime, anyplace computing. The need for ubiquitous software deployments, virtual environments, software acceleration, economies of scale, and on-demand services points to the SPSU cloud computing solution for expedient network access to a pool of shared resources.
Information security and data assurance reside at the heart of academic and business operations. Keeping data and information secure and available in a dangerous, globally networked environment is paramount and requires strategic layers of physical, network, application, and data layer security. Moreover, the socio-technical aspects of security, such as those seen in social engineering, require cultural norms and civic awareness and training to ensure security requirements are met.
New identity management processes were also put in place to protect network resources from being accessed by unauthorized individuals. Moreover, a single point of entry for all persons entering the campus data center area on the lower floor of Building H is now the UITS Help Desk. At the Help Desk, all visitors to the data center area will be required to sign in and sign out upon arrival and departure.
To accommodate the mobile computing needs of the campus and associated models of computing, such as BYOD, a redesign and construction of campus Wi-Fi network infrastructure is required. As part of a 3-year phased project, the university wireless infrastructure is being reconstructed to ensure optimal capacity and coverage campus-wide. Building J and Building R, Norton Hall, were the first to complete redesign and reconstruction this year and take the first step toward homogeneous infrastructure with new next-generation Enterasys access points, or APs. The APs, known as Identify, are purpose-built to meet the security, reliability, density, and availability required by the university to support the high on-demand traffic from mobile and BYOD users. Also during this year, Building A and Building C Wi-Fi infrastructure were redesigned and reconstructed.
Over a 3-year period, redesign and reconstruction of the university Wi-Fi network will be completed. Building by building and area by area, the university Wi-Fi infrastructure will provide appropriate provisioning for mobile and BYOD computing. The new campus Identify APs enable the university to manage and control the increasing influx of wireless devices resulting from BYOD and enterprise mobility initiatives. This technology provides an exceptional user experience in what is termed a hyperdense Wi-Fi environment.
New and innovative modes of learning are widely dependent on digital content. In the 21st century, a repository for academic content, including digital learning objects, is required to support various modes of instruction. To support faculty needs for delivery of digital content, whether text, graphic, audio, or video, the CDN represents a centralized, secure, available, and searchable repository and delivery mechanism that provides the functionality required by teaching faculty, instructional designers, students, and other stakeholders in the academic environment.
Teaching faculty, particularly in a polytechnic institution, requires environments that support applied learning, action research, testing, and experimentation. Moreover, students in polytechnic programs benefit from hands-on environments that provide for experiential learning and simulation of real-world models and events. The Academic Research Network will provide for secure routing to the commodity internet without crossover to existing production network routes.
Higher education institutions today exist in a competitive environment that requires support for data-driven decisions. Certain unique technology environments support the transformation of transactional data into analytically processed data. Longitudinal views of data that support analysis of trends, patterns, and behaviors in the data are needed to support administrative and academic decisions, qualitatively improve instruction and services, and guide operational and financial planning. This initiative also serves to create an operational data store, or ODS, that supports business intelligence tools, namely Cognos. Merging disparate data sources into an ODS will create a robust data environment from which appropriate university stakeholders can better make data-driven decisions.
In the new century, IT organizations not only function as a provider of technology, infrastructure, and services, but as an enabler of data-driven strategies and decisions. Decision support systems, in the form of real-time online analytical processing, provide the required business intelligence, or BI, for academic institutions to operate and thrive in a competitive and challenging landscape. Moreover, stakeholders as end users of the BI will be empowered at the desktop level to access and query operational data stores populated with new and relevant institutional data sources.
As 21st century academic concepts shift from a focus on teaching to a focus on learning, the reference to physical and virtual classrooms as learning spaces has gained attention and acceptance. To support SPSU initiatives that advance conceptual models of education, such as convergent instruction, strong focus and attention must be given to classroom and educational technology planning, requirements, design, development, testing, implementation, and support.
The learning space concept interoperates with two additional key drivers: technology and mode of instruction. This initiative works to develop and implement a framework in support of convergent models and instruction, sustainable learning spaces, and innovative learning platforms. By working in collaboration with teaching faculty, students, instructional designers, and other stakeholders in the teaching learning process, the Classroom Technologies Group within UITS will describe, implement, and maintain supportive, convergent learning spaces and configurations based on university needs.
Physical and virtual classrooms and learning spaces demand designs that work in concert with technology and pedagogy. As the university continually strives to improve pedagogy and andragogy, the intersection of learning space and technology becomes a critical concern in the design, development, and delivery of academic programs. As university community stakeholders in education come together to form a framework for education delivery in the new century, quality assurance and continuous improvement become important elements in ensuring effective, reliable, secure, and available learning spaces.
To promote innovative and progressive conversation regarding university technologies, mechanisms that support cross-functional collaboration and dialogue are important. Such mechanisms can create a university community conversation among all stakeholders in academic and administrative computing. As a university community and as a polytechnic institution, Southern Polytechnic State University now benefits from stakeholder involvement at all levels in conversations regarding the current and future directions of academic and administrative computing. University information technology initiatives are socio-technical in nature and require technology solutions that provide clear demonstrations of business and educational value. UITS will continue to promote a functional, collaborative, and dynamic campus technology community.